All right, Matt 2, here we go. We got lesson 5.2.5, solving and applying quadratic equations. All right, so for starters, we've got 6 problems here, and we've got a lot of different methods for solving quadratic equations. I mean, we could use the zero products property. We could take square roots of both sides. We could complete the square. We can use the quadratic formula. Now, the thing is, zero products and square roots are pretty fast ways to do it. The problem is they don't always work. So these two don't always work. Completing the square and quadratic formula always works, but they're usually the longer methods. And plus, when we do completing the square, we usually only want that middle term to be an even number and no x squareds on it. So let's look at each of these problems and decide which method works best with it. So when I come across a problem, the first thing I ask myself is, can I factor it? Because if I can factor it, that's probably the fastest way to do it. So I ask myself, is there a way to factor this one? Let's see. Does anything multiply to give me 27 but add to give me 12? So 27 could be 1 times 27 or 3 times 9, and 3 times 9 does add up to give me 12. So the fastest way to do this one is using the zero products property because it factors. So this one I can just say is x plus 3 times x plus 9. And then using zero products, I can say x plus 3 equals 0 and x plus 9 equals 0. So I can subtract 3 from both sides and get one of my answers as negative 3. Subtract 9 from both sides and get my other answer is negative 9. So my two answers are negative 9 and negative 3. Pretty quick because I knew how to factor. Next one, I asked myself, can it factor? And yes, it can. It's only got 2 terms, but they're both perfect squares. So I could use the difference of 2 perfect squares. This is the perfect square of 2x, and this is the perfect square of 11. So I would do 2x plus 11, and I could use 2x minus 11. And maybe you thought we could use the square root method and add 121 to both sides, divide by 4, and then take the square root. And yeah, you could have done that too. You would have gotten the same answer and probably just as fast. So this one, I would now just do 2x plus 11 equals 0. 2x minus 11 equals 0. So over here, I'm going to subtract 11 from both sides, and 2x is negative 11. Divide by 2, and x is negative 11 halves. Over here, I'm going to add 11 to both sides. 2x equals 11. Divide by 2, and x is 11 halves. So my answer for this one gives me 2 answers, 11 halves, and negative 11 halves, and positive 11 halves. Next one. This one's already in factored form. So the best way to do it is just zero products because it's already ready to go. So we can now just do 3x plus 4 equals 0 and 2x minus 1 equals 0. Over here I'd subtract 4 from both sides and get 3x equals negative 4. Divide by 3 and x is negative 4 thirds. Over here, add 1 to both sides and get 2x is equal to 1. Divide by 2 and get x equals 1 half. My answers are negative 4 thirds and positive 1 halves. Next one. So for this one, I would probably want to put it into standard form first just to see if it factors. So I'm going to subtract 8x from both sides. And add 4 to both sides. So this leaves me with x squared minus 8x, 12 and 4 makes 20, equals 0. So here I've got 20. I'm going to ask myself, are there any factors of 20 that add up to negative 8? You might be tempted to say something like negative 10 and 2, but one of them's positive, one of them's negative, and when you multiply them, you're not going to get positive 20. So you might be thinking, okay, 20, what multiplies to give me 20, but adds to give me 8. You can start going through your different options. You got 1 and 20, 2 and 10, 4 and 5. There's all of our options. None of these have subtract to give us 8, where one of them's positive, one of them's negative. Never mind. Oh, they have to both be negative. Sorry. They both have to be negative because we're multiplying to give a positive 20 and we're adding to give negative 8. So yeah, this doesn't work. These would both have to be negative. This gives you negative 21. This gives you negative 12. This gives you negative 9. None of them give you negative 8. I can't do the principle of zero products because it doesn't factor. So what else can I do? Can I do square root method? No, that's not going to work. Can I complete the square? Yeah, I could complete the square. And as a bonus, there's no leading coefficient here, and this is an even number. So completing the square might be faster than using the quadratic formula. So that's what I'll do. I'll complete the square. I'm going to subtract 20 from both sides. So this gives me x squared minus 8x. I'm going to leave a blank here. Equals negative 20. Oh, that's 16, not 20. Duh. Oh, well, I already screwed it up. So, it's been a long day, okay? Man, what am I doing today? Anyway. All right, so I'm going to cut this in half. And then square. So I get negative 4 squared, which is 16. So 16 is the number that I'm going to add to both sides. It's going to add 16 here and add 16 there. So what perfect square did I make? Well, the number that I squared was negative 4, so this is x minus 4 squared. And over here I get 0. So I'm going to take the square root from both sides. And I get x minus 4 equals plus or minus the square root of 0. Add 4 to both sides. And I get 4 plus or minus the square root of 0 is 0. So 4 plus 0 and 4 minus 0 are the same answer. I only have one answer of 4. Now, because I messed this one up, I probably could have seen that it factored. I could have done principle of zero products for this one, but I messed up, so whatever. Moving on. I want this to be in standard form, so I'm going to subtract 60x from both sides. So I get 36 x squared minus 60x plus 25 equals 0. Now you can check to see if it factors, and this is actually a perfect square because this is the perfect square of 6x, and this is the perfect square of 5, and then 6 times 5 is 30, and this is double that amount. So this one's actually a perfect square if you go back to our patterns for binomial squares. Let's say that we don't know that. Let's say we don't know that this one factors. Okay, so pretending like it doesn't factor. So at this point, I would say, okay, if it doesn't factor, should I complete the square? Probably not, because we got a leading coefficient. Okay, so what am I left with? I'm left with the quadratic formula. So let's just do the quadratic formula on this big ugly one here. So I got x equals negative 60 plus or minus the square root of negative 60 squared minus 4 times a, which is 36, times c, which is 25. Running out of room. All over 2 times a, which is 36. All right, cleaning up my 4 spots. Going to clean up this spot first. I get x equals 60 plus or minus the square root. 60 times 60 is 3,600. Negative 4 times 25 is negative 100. Negative 100 times 36 is negative 3,600. And then 2 times 36 is 72. All right, so I get x equals, combine those two, 60 plus or minus the square root of 0 over 72. So this is just 60 over 72, because 60 plus 0 and 60 minus 0 are the same thing. 12 does go in both these numbers. 12 goes into 60 5 times, and it goes into 72 6 times. So we have an answer. One answer, 5 over 6. So if we would have noticed that this was a perfect square at the beginning and factored it that way, that would have probably been the fastest way to do it. Here we go, next one. Do all these factor? Maybe I should have read ahead and checked. Over here, minus 45. So I'm going to subtract 45. So I get 20x squared. Here I get negative 32x and minus 45. All right, does it factor? Well, I don't really feel like finding out. It looks like the numbers are pretty big. I don't want to find out if 900 has factors that add up to 32. That doesn't sound like fun. I don't want to complete the square on this one. Even though the middle term is even number, I've got a leading coefficient, so that doesn't sound like fun. Doesn't look like I can do a GCF factoring on here, so I'm just going to do the quadratic formula for this one. So x equals negative 32 plus or minus the square root of negative 32 squared minus 4 times a, which is 20, times c, which is negative 45. Oh, ran out of room. Kind of had room. All over 2 times 20. All right, clean up. So we've got x equals negative 32 is 32, plus or minus the square root. I don't know what 32 squared is. 32 squared is 1,024. 4 times 20 is 80, and 80 times 45 is 3,060, and it's positive 3,060. No, 3,600. All over 2 times 20, which is 40. So we had a negative and a negative here. That's why I was positive that. Okay, I'm going to combine my like terms. So I've got x equals 32 plus or minus. Here I've got 4,624. That sounds like a perfect square. Let's see. So 4,624. Yep, it is a perfect square. So this one did factor, but we didn't have the patience to figure that out. It comes out to 68 here. So 4,624 is the perfect square of 68. So now I can check for my two answers. 32 plus 68 is 100 over 40. 32 minus 68 is 36. Negative 36 over 20, 40. All right, I can reduce both of those. 100 over 40 is 5 over 2. So this one is 5 over 2. And let's see, 4 goes into 36 and 40. Does anything else go in there? I don't think so. So 4 goes into 36 9 times, and it goes into 40 10 times. So there's my two answers, 5 halves and negative 9 tenths. So anytime we're getting these whole numbers here, it tells us it did factor. So it turns out all 6 of these factored. But maybe we can't figure out how they factor. If we can't figure out how they factor, we should go back to one of our other methods for solving. All right, word problems. 2 word problems, then we're good to go. Gabby is building a fence to keep deer out of her garden. One side of her garden is against a wall, so she only needs to build 3 sides of the fence. Okay, so I've got a wall here. There's my little brick wall. All right, so she's got a wall there, and she's going to build a fence off of that wall. So here's the garden. So she's got 3 sides to the fence. Okay, she's got 100 feet of fencing, so these 3 sides have to add up to 100. If she needs to enclose 600 square feet, so the garden here, this is 600 square feet. What would the length and the width of her fence be? All right, so it's not a true perimeter because it's only this side and this side. Maybe these are our widths. So I don't want multiple variables. I only want one variable. So far, I've got x and x taken up out of the total of 100 feet that I can use. So I'm going to make this last side 100, but then take away these 2 x's. So this side would be 100 minus 2x. So our width is going to be x. Our length is going to be 100 minus 2x. So width of our garden is x. Our length of our garden is 100 minus 2x. Because I can use 100 feet total. So if I take away these 2, I'm left with 100 minus whatever those 2 are. Okay, so area is just width times length or length times width. So my area is going to be 600 equals the width of x times 100 minus 2x. All right, I'm going to go ahead and distribute this. 600 equals 100x minus 2x squared. I usually don't like having negative x squareds. So I'm going to move everything this direction. I'm going to subtract 100x from both sides. I'm going to add 2x squared to both sides. All right, so I'm putting it in standard form here. I get 2x squared minus 100x plus 600 equals 0. Now I'm noticing that I can simplify this a little bit because all these numbers are divisible by 2. So just to make it a little bit easier, I'm going to factor out a 2. So this would give me x squared minus 50x plus 300. All right, so here's my equation in standard form with the 2 factored out so that I have smaller numbers to deal with. So at this point, looking at it, I'd have to ask myself, does anything multiply to give me 300 but add to give me negative 50? And I'll tell you the truth, I don't really feel like thinking that hard today. So I'm not going to look for all those factors. Instead, I'm going to use one of my solving methods. And personally, I'm going to complete the square. I'm going to complete the square because I don't have a leading coefficient anymore because I factored out this 2. And this number is divisible by 2. So let's complete the square over here. So I've got x squared minus 50x blank equals, I'm going to subtract 300 from both sides. Negative 300 and then blank. So now I have to find out what number I need to add to both sides. And remember what we do is we take half of this and square it. So I'm going to take negative 50, cut it in half, square it. So this is negative 25 squared. 25 times 25 is 625. So I'm going to add 625 to both sides. So let me double check 25 times 25. I don't trust myself today. Yeah, it's 625. All right, so we've got x minus 25 squared because 25 is the number that I just squared up there. Negative 300 and 625. This would be 325. I'm going to take the square root from both sides. And I get x minus 25 equals plus or minus the square root of 325. 325. Dang it. All right, I'm going to add 25 to both sides. I get 25 plus or minus the square root of 325. Okay, I'm going to just take out my calculator and find out what 325 is. I mean, this is an answer, but, you know, nobody wants to leave your answer like this when you're talking about a problem. Because if I told you, oh, I'm going to kill those lights. I'm going to destroy you. All right, so going back to this. It's like every 15 minutes they turn off. It drives me crazy. All right, so I'm going to work this out. 325, what was that? Yeah, square root of 325. It's about 18. It comes out to 18.02. I'm just going to call it 18, just approximately. So this is going to be x equals 25 plus or minus 18-ish. Close enough. So this is an approximation. So 25 plus 18, that would be 43. And then 25 minus 18 would be another answer of 7. So there's two answers for the width. One of my answers for the width is 43. That's my width. If 43 is my width, my length would be 100 minus 2 times 40, or yeah, minus 2 times 43. 2 times 43 is 86. 100 minus 86. So we're doing 100 minus 2 times 43. So this is 100 minus 86, which would be 14. So there's one combination. I could make these two sides 43, and I could make this other side 14, and that would work. Because 43 times 14 is about 600 square feet. So that's one answer. My other answer says that my width is 7. So if both of these are 7, my length then would be 100 minus 2 times 7. Or 100 minus 14, which would be 86. There's my other answer. So we actually have two separate answers. A 43 by 14 area or a 7 by 86 area. Both of those could work. All right, we got one more problem and then we're good to go. Last problem. Karen drives straight south on Interstate 405 from the Santa Monica Freeway interchange, going 10 miles per hour, faster than Melinda, who leaves the same interchange at the same time, going straight east on Interstate 10, on I-10. All right, so she's going towards Phoenix. After 1 hour, they are 108 miles apart, measured by a straight line drawn between them. How fast is each driver going? We need a drawing. So, Karen leaves straight south. Okay, so Karen's right here. She's going to go south on the 405. So she goes straight south. She's going 10 miles per hour, faster than Melinda. Okay, so here's Karen. So she's on the 405. She's going to go straight south. Melinda is going to go straight east on I-10. So she's going straight east. There's Melinda. It says after 1 hour, they are 108 miles apart. So that's this diagonal distance here. So the distance there is 108 miles. All right, we want to know how fast each driver is going. There's a little bit extra that we need. We are going to use the distance formula. Distance equals rate times time. Okay, so we're going to do the distance for each of them, the rate for each of them, and the time for each of them. So for this first one, I've got to take into account that she's going 10 miles an hour faster than Melinda. So I'm going to write that Melinda, her speed is going to be R. And then Karen, her speed is going to be R, 10 miles per hour faster is going to be R plus 10. So what we have here is a Pythagorean theorem problem mixed with a distance equals rate times time problem, which makes it real fun. So the distance for Karen, her distance is the rate. Her rate is R plus 10 times her time. Now it says they're both going to go for 1 hour. So they're all going to go for a time of 1 hour. So her distance is R plus 10 times 1. So the distance over here is just R plus 10. Melinda, her distance is just going to be R times 1, or just R. So this distance squared plus this distance squared should equal this distance squared. So Melinda's distance, which is R times 1, or just R, squared, because we're using the Pythagorean theorem, because this is a right triangle, plus Karen's distance, which is R plus 10, squared, equals the hypotenuse, which is their total distance here, of 108 squared. All right, work these out. This is just R squared. This one here, R plus 10 times R plus 10 is R squared plus 20R plus 100. If you do the area model, you'd see that's what you get for this one. And then 108 times 108, I can't do that in my head. 108 times 108, 11,664. So we get that. Combine the like terms here. We get 2R squared plus 20R plus 100 equals 11664. I'm going to subtract this from both sides. That gives me 2R squared plus 20R, and this is negative 11564. They're all even. Let's factor out a 2. So I'm going to factor out a 2. I get R squared plus 10R. It's 11564 divided by 2. 5782. All right, so at this point, what are we going to do? So I'm looking at this. I can use the Pythagorean theorem if I want to. Not the Pythagorean theorem, I already used that. I can use the quadratic formula, or since this number's even, and I don't have a leading coefficient since I factored out that 2, I can just use the completing the square method, which I will do. So I've got R squared plus 10R minus 5782 equals 0. Some of you might be saying, where'd this 2 go? Well, if I divide both sides by 2, it just goes away, because 0 divided by 2 is 0. So I'm just going to pretend like it wasn't there. So I'm going to isolate the r squared and the 10r. I'm going to leave a blank here. And there I'm going to get 5782. Leave a blank over there. I'm going to take half of 10 and square it. So that's 5 squared, which is 25. So that's the number that I add to both sides. So this leaves me with a perfect square over here. The number I squared was 5, so this is r plus 5 squared equals 5708. I'll take the square root from both sides. And this gives me r plus 5 equals plus or minus the square root of 5708. I'm going to subtract 5 from both sides. That gives me r equals negative 5 plus or minus the square root of 5708. Okay, so let's just approximate 5708 on our calculators. So if I take 5708 and take the square root of it, it comes out to about 75.6, let's call it. 75.6? Yeah. So I'm going to say that r is equal to negative 5 plus or minus 75.6. Now at this point, I get two answers. 75 or negative 5 plus 75.6. That would give me 70.6. My other answer is negative 5 minus 75.6, which would give me negative 80.6. Now, it's impossible that they would be going a rate of negative 80.6 miles per hour. So let's not even look at that answer. Looks like there's only one answer that makes sense. It looks like Melinda, way up here, is going 70.6 miles per hour. And Karen is going 70.6 plus 10. She's going 80.6 miles per hour and is going to get pulled over. So Melinda, she's going 70.6 miles per hour because she's R and R is 70.6. And then we've got Karen. She's 70.6 plus 10, so she's going 80.6 miles per hour. I took up a lot of space. All right, we're done. You can go take a nap because I'm going to go home. All right, see you guys.